Hi everybody, it's me again, Mr. Bailey, and today I'm going to talk you through as best I can the second paper on November 2027 series from Edexcel GCSE Higher Tier Maths. Sometimes I'll show you more than one way, but I'll try and strike a balance between being as clear as I can without going on for too long. I appreciate you don't want to spend hours of your time watching maths videos, or maybe you do, but if so, you might be in the minority there. Anyhow, so I'll get started. So let's look together at the very first question. So here we've got a relatively gentle opener. If you've practiced these enough, we need to solve this equation. So the first step is we're going to expand these brackets here. That's going to give us 5x minus 6 equals, well, 3 times x gives us 3x. 3 times minus 1 is minus 3. This method I'm going to show you next is a love-hate thing. Some teachers don't like it. You need to be careful when you're doing it, but as long as you have enough practice doing it, it does work pretty well, I think. I'm going to just swap for sides and swap for signs. Mathematical music chairs. You've got x's on both sides here. You need all the x's together. So in real life, would you move a heavy thing or would you choose to move a light thing? For health and safety, I'd hope you'd suggest to move the smallest thing first. So you move the smallest number of x's across. 3 is less than 5, so we're going to move these 3 x's to the other side. It doesn't say they're negative, so they must be positive. When we swap the side, though, they swap sign, so we subtract, essentially, the minus 3x from both sides. Over here, 5x minus 3x gives us 2x, minus 6. Over here, we just have minus 3 on its own. We also want the digits, the numbers on their own, on the other side. So that 6 is a minus. If we swap the side, we swap the sign, we think of it as a plus on the other side. What's actually happening is we're adding 6 to both sides. So 2x will be minus 3 plus 6. If you're not sure, use one of these things. It is a calculator paper after all. Don't make any silly errors with your negatives. And with it being a calculator paper, there's not really any excuse for you making those mistakes. So minus 3 plus 6 gives us 3. Finally, we just divide by 2. So x will be 3 divided by 2, which you can say is 1.5, or 1.5 if you prefer. As long as it's an equivalent of 1.5, you're absolutely fine. So we're off and running. Let's have a look at the next question. So here, Emily's bought a pack of 12 bottles of water. The pack costs £5.64. Emily sells all 12 bottles for 50p each. Okay, so money she gets, so the money she gets from the sale is going to be those 12 bottles multiplied by 50p, which is 0.50. You can do it in pence if you want to, but at any rate, you should find that's £6. So therefore, her profit's the difference in between money made, money she takes in, subtract money she had to spend in the first place. So she's taken in £6 from these sales, but of course she had to spend that £5.64 to buy them in the first place. So we do £6 minus the £5.64, and with a calculator or not, you should find that's 36p. I'm choosing here to do it all in terms of pounds. So next, we need to work out Emily's percentage profit. Well, what I'd suggest you remember is the general formula for a percentage change, whether it be a percentage increase, decrease, or percentage profit, percentage loss. It's always the change divided by the original amount, multiply that by 100. So in Emily's case, her percentage profit is going to be her actual profit divided by what she paid. The original cost to her was this £5.64. So I'm just writing out how you'd adapt this general equation. So in terms of plugging in our values now, the profit she made was 36p. The original cost to Emily was £5.64. We then multiply that by 100 on the calculator. Don't even dream of trying this without the calculator. So what we're going to get here is 0.36 divide 5.64. All of that multiplied by 100. That's going to give us 6.38, going on for an awful long way. But let's read the question carefully. Give your answer to one decimal place. So we get 6.38, so on and so on. We want it to one decimal place, like it says. So that means you want to keep one digit after the decimal. We want to keep this digit here. The only question now is, does that 3 stay as it is, or does it round up? Well, next to the 3 is an 8, which forces that 3 to round up. So that 3 becomes a 4. Therefore, her percentage profit, correct to the one decimal place we've been asked to give it to, is 6.4%. Let's now check out the next question. So, question 3. Hasmeet's walking once around a circle that has a diameter of 80 metres. There's 8 points equally spaced on the circumference of the circle, which we can see here, A, B, C, D, all the way to H. So 8 different points, we've got 8 different spaces. If you're not sure, feel free to just count them. So you've got here, for example, 1 space, 2, 3, 4, 5, 6, 7, 8, then back to where he began. We need to find the distance he walks between one point and the next point. So if we're thinking about the distance he's walked from one point and the next point, we're just wanting a fraction of the full distance around the circle, and the distance around the circle is the circumference. So first of all, let's work out the circumference of the circle. Circumference is pi times diameter. Don't get it confused with the area, which is pi r squared. I remember this as terms of chicken pies are delicious, apple pies are too. So we're using this one here, we're using C equals pi d. So we've got pi times 80, because the diameter is 80, because it very nicely says that in the question. So type it on a calculator, see what we get. So we do shift this button here to get pi on this calculator, pi times 80. You can leave it like that if you want for now. 80 lots of pi. So, like I've said before, the distance from one point to the next is just 1/8 of that full circumference. So therefore, the distance between the points that's just going to be the total circumference, which is 80 pi, divided into 8 equal pieces. So that divided by 8, that'll give us 10 pi, which the calculator would say, just to show you here. If you divide that by 8, get 10 pi, but we want it as an actual number in terms of meters. So if we press S arrow D next, to one decimal place or 3 significant figures, we can see it's 31.4 meters. And that's part A sorted out. Next, we've got part B. So here it says further points are moved, as shown in the diagram below. So these points here, I'll just move the diagram to the side. I know it says below in the question paper, but anyway. So the points have been rejigged a bit, they've been moved around. He wants to walk once around the whole circle again. Has the mean distance that Hasmeet walks between one point and the next point changed? You must give a reason for your answer. What I'd suggest we do here is think about how you actually calculate the mean of anything. The mean is always the total divided by how many things we're talking about. So to work out the mean distance between points, it'd be the total distance, the circumference, divided by how many points, which is 8. Well, the circumference hasn't changed. It's still the same circle. We've still got 8 points. So therefore, it would literally still average itself out to be the same. So in terms of wording or what to put for the examiner, I'd suggest something like this. So ultimately, no. The mean distance between points is the total distance divided by number of points. Since neither the total distance, which is the circumference, nor the total point, which is 8, they haven't changed, therefore the calculation for the mean is identical, so the mean will still be the exact same thing. Question 4, we're talking about cubes here. There are only blue cubes, yellow cubes and green cubes in a bag. There are twice as many blue cubes as yellow cubes and 4 times as many green cubes as blue cubes. Right now my head's spinning. I would suggest you picture this, maybe even by doing a diagram. So I'm just going to show you how you might want to picture this by actually getting some of these cubes up on the screen. So we've got blue cubes, we've got yellow cubes, and of course it says we have green cubes. So let's read the bits and pieces carefully. I'll just section these out here so we don't get in the way of my working, which will be in this space here. So we're told first of all, there's twice as many blue cubes as there are yellow. So let's compare blue to yellow. So that means for every one we've got which is yellow, yoink, just grab that there, we've got twice as many which are blue. So for every 1 yellow, we've got 2 blue. But next it says about these green cubes. So it's next saying there's 4 times as many green as blue. Well, if there's 2 blue, 4 times as many as 2 is 4 times 2, which is 8. So the number of green we'd have would be 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm not suggesting you have to draw a nice cube like I have. I'm just showing you a way you could literally picture this. You can maybe do little circles or sketches, or you could do it as a fairly standard ratio question. Anyway, now, she's going to take at random a cube from the bag. Work out the probability that Hannah takes a yellow cube. So the probability she takes a yellow will be the same as the proportion of these cubes which are yellow. So using this little diagram here, you can say there's only 1 yellow out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in this sketch. So the chance for picking a yellow is the same as the proportion which are yellow in this little diagram, which is 1 out of 11, or 1/11th. So that's a way where we could just do some diagrammatic maths to help us tackle a question which otherwise sounds a bit wordy, dare I say. Hope that's helped. That's question 4. Question 5 is one of these rotation questions. So rotate trapezium T, which is here, about the origin, label the new trapezium A. So what we need to do for this one is just think about what the question's saying. So first of all, it's a rotation about the origin. The origin is just the centre, it's the point 0, 0, so let's label this on. You don't have to, but I do think the easiest way of doing this is with some tracing paper. So I'd suggest you get some tracing paper and trace round the original shape T as accurately as you can. So there's one I made earlier, just on top of the trapezium T. Next, you want to rotate this trapezium about the origin. So rather than trying to turn the paper, I'd suggest you literally stab the centre of rotation with something sharp, for example a pen, a pencil, or even a compass. So with a compass I've got here, hold it down over the centre, get your tracing paper and carefully rotate it half a turn around. Doesn't matter if you go anti-clockwise or clockwise, that's a 90-degree turn. Keep going until you got half a turn. And you can see that's where it's going to land up. So that's where it becomes. So take the tracing paper off and record these points and make sure it's clearly labelled as trapezium A. So on the next slide, here's what you need to do. Label it clearly trapezium A. Finally, part B, we're forgetting trapezium A now. We're going back to trapezium T. Translate it by the vector -1, -3. So if you have a column vector translation, the top number tells us how far to the right you're moving. Because that number's negative, it means you're going to move it 1 to the left. The bottom number tells you how far up you're going. Again, because that's negative, that means instead of going 3 up, we're going to go 3 down. So what we're going to do here, again, you could trace over or just think about the points. So for example, just picking any point, for example, this corner here, that corner is going to go 1 left, then 1, 2, 3 down. That corner there needs to end up going here. So what we could do is something like this. Get it? We're going to move 1 to the left, then 1, 2, 3 down. It's going to end up there. So what I need to do here is follow the instructions, label that B, like so. And because I love colouring in, I don't know why, I'm going to colour this B. Actually, I do partly know why. So that if you're watching on a smartphone, if it's an old smartphone or with a small screen, this hopefully will make it clearer for you. So that's where shape B should go, and for part A, that's where shape A goes. So that's question 5 done. Question 6, we've got some laws of indices to look at. So we've got here that p cubed times p to the x equals p to the 9. Work out the value of x. So we need to remember that when the base values are the same and we multiply them involving powers, then we can work out the new power by simply adding these powers. So essentially all we're doing here is spotting that when we do this power added to x, we need to have 9. That's all we're doing. So it's a very simple equation, 3 plus x equals 9. If you just spot already that it's 6, that's absolutely fine. So 3 plus x equals 9. You don't need to write this down, I'm just explaining why it's 6. Therefore x is 6. It's because when we do one power multiplied by another, to work out the new powers, we just add the powers together. So that one, x is equal to 6. This one here, and to find the value of y. Now when we take something to a power and multiply it by another power, we multiply these two powers together. And so what it's saying here is 7 to the 2 times y, 7 to the 2y, equals 10. In other words, this one, my bad, I mean 7 to the power 10, that's what I wanted to put down. Remember 2y must equal 10. And if 2y equals 10, then therefore y equals 5. And once again, if you just saw that straight away and knew how to do it, that's fine. This one here, we've got 100 to the power a times 1000 to the power b, can be written in the form 10 to the power w. This is a show that question, so the calculator can't really help us. So what we need to do here is just be thinking, what do we need to do with 100 and 1000? We want to show it can be written in the form 10 to the w. So what we need to do is get these 100 and 1000 in terms of 10. So 100a times 1000b can be rewritten. So 100 is obviously 10 times 10, so I'm going to rewrite 100 as 10 squared. So it's 10 squared to the power a, and 10 cubed gives us 1000, so 1000 is the same as 10 cubed. So again, like we did with part B, if we've got a power of a power, we multiply these powers together. So 10 squared to the power a is the same as a power 10 to the, so same as 10 to the power 2a, sorry. And 10 cubed to the power b is the same as 10 to the power of 3b. Making a mess of this, sorry, I mean multiply. So now going back to part A, when we multiply powers together, we simply add the top numbers. So this as an overall power of 10 will be 10 to the power 2a plus 3b. So if we want to write it in the form 10 to the power w, where w is just some number we want to find or some value, when we've done this, we've done it in terms of 10 to a certain power. So here, the power of 10 we've got just happens to be 2a plus 3b. So therefore, this w here must be the same as 2a plus 3b. In other words, Therefore, W equals 2a plus 3b, like we've shown. Question 7. ABCD is a trapezium. We need to work out the size of angle CDA. So what are we trying to find? Trying to find angle CDA. We go for the middle letter. So CDA, we go for the middle letter out of C, D and A. So it's the angle at D here, which is this one. So we need to give the answer correct to one decimal place. So what we need to do here is think about how we can get close to knowing something surrounding this angle CDA. We're not close to knowing enough information yet. But let's think about what we are told and what we can work out. Generally, if you're not sure what to do, if you can work out something, do work it out. Well, a trapezium has a constant distance between the parallel sides of it. So if this distance here is 6, I can label in that the distance between C and the base must be 6 as well. So it can't hurt me to do that first of all. So this distance from C to the bottom is going to be 6 centimeters. So I'll label this on. Now, to find an angle here, I know this is a right-angled triangle now. I know one side of this right-angled triangle, but I don't know the other. I don't know this hypotenuse, and don't know this base. I do know the full length from one end to the other of the trapezium is 24. But now, if I cast my eyes over here, this triangle as well as right-angled, and more than that, I know two sides of it. I know for this triangle I'm currently colouring in green, its hypotenuse is 7.5, and another side is 6. So what I can do over here is apply some Pythagoras. So if I wanted to work out this side here from A to the bottom, if I just call that x, for example, then using Pythagoras, then the short side squared plus the other short side squared, in this case x squared plus 6 squared, that has to equal the longest side squared. So that equals 7.5 squared. Rearrange. So x squared is 7.5 squared minus 6 squared. Finally square root both sides. So x must be the square root of whatever 7.5 squared minus 6 squared is. So let's calculate this now. So square root 7.5 squared minus 6 squared. That gives us 4.5. So this bit I can just actually put in what it is a bit more neatly. Oops, I won't do that. So from one end to the other of this bottom small triangle, it's going to be 4.5. We're also told, I'll go to that line as well, we're told that the top end of this trapezium is 10, so this bottom bit will also be 10. So what we can actually hopefully see now is if the whole length is 24, this bit's 4.5 and that bit is 10, I can work out this bit here. This bit will just be 24 minus that 10 minus 4.5. So 24 minus 10 minus 4.5, that gives us 9.5. So the base of this triangle, which includes the angle I'm trying to find, is 9.5 centimeters long. So now I can just focus in on this triangle because I know the opposite side and know the adjacent, so I can be thinking of Pythagoras. So all this I've done now can sort of be forgotten. I'm just focusing in on this one here. That's all I'm interested in now. All the other bit of this trapezium was just a means to an end to arrive at this information. It's a right angled triangle. I know two sides, so it's going to be trigonometry. So SOHCAHTOA is what we need to remember. So that's in the way slightly of this writing. I'll just shift it to the side. There we go. So SOHCAHTOA. So we know the opposite side. Opposite to the angle I'm trying to find is 6. So anywhere we can see an O, tick it, because we can use that information. Hypotenuse is the longest side, which is this one. I don't know that, but in fairness I don't really want to know it, so it's no loss. The other side, if it's not the O or H, is the adjacent. That I do know as well, it's 9.5. So tick where I see an A for adjacent. Then if I use SOHCAHTOA, which one do I go for? We go for the triangle which gives us the most information, the most ticked triangle, if you want to think of it that way. And that's going to be TOA. To find an angle, we have used the S, C or T. Because to circle this triangle we use tan, but because we're finding an angle, T now stands for tan minus 1. It's tan minus 1, O on top, A on the bottom. So it's tan minus 1, the opposite is 6, divided by the adjacent, which is 9.5. So shift button, then tan, 6 divided by 9.5. Press equals, get this answer here. Now the exam paper says give your answer to correct to one decimal place. So this one here, the first number after the decimal is a 2, but next to that 2 is a 7, so we round the 2 up to a 3, so it's 32.3 degrees. And we're done. Question 8, some calculator skills here. So write down all the figures on your calculator display. This is an absolute gimme question, but you'd be surprised how many people get this wrong by just not learning how to use their calculator properly and confidently. So assume you've got a Casio. I can't recommend Casios enough. I apologise to all the people that work at the other calculator brands out there. We just type it in exactly as it looks. The Casio is a lovely calculator. I might be going a bit too far with my love for Casio, but anyway. So sin 25, so type sin 25. Now close the bracket. This is where people can make a mistake. Close that bracket off. Then plus sin 40, close the bracket off. Underneath, cos 25, close the bracket again. And minus cosine 40, and again, close that bracket. Press equals, and we get this here. So it does say write down all the figures on your calculator display. So we're going to write down 2.756. 03957. Part B is based off Part A. For Part B, you have to write the answer to Part A correct to 2 decimal places. So to 2 decimal places, we want to cut it off after the 2 numbers that come after the decimal. So we want to cut off after the 7 and the 5. We can see here, after this 5, there's a 6 next to the 5. And so this 5 will be forced to round up to a 6. So that just becomes 2.76 to 2 decimal places. Question 9. Yesterday it took 5 cleaners 4.5 hours to clean all the rooms in a hotel. There are only 3 cleaners today to clean all the rooms. Each cleaner's paid £8.20 for each hour or part of an hour they work. How much will each cleaner be paid today? These can be quite hard to picture. These are like a new style of ratio question, which are now quite big on this new, more challenging specification. So let's just think step by step and try and picture it out, what's going on. We've got 5 cleaners, so just picture 5 people. Here they are, looking ready to clean. I'm looking happy to do their job as well, so good for them. So it took them 4.5 hours each to clean all the rooms in the hotel. So they're working at the same speed. So each one of these people has worked 4.5 hours each. So just label this in here. So she worked 4.5 hours, he worked 4.5, she does 4.5, and so on and so on and so on. So in total, how much is that for one person? If 5 people take 4.5 hours to do that work, how much work is it for just one person? We just multiply 4.5 by 5. So 4.5 times 5 is 22.5 hours of work for one person. So what changes now is, today there's not as many cleaners available. If there's fewer cleaners, there's only 3 cleaners. So we need to say goodbye to 2 of them. So 3 cleaners, so I'm just going to keep the ones in the middle. So we just got these 3 people here. So these 3 people, between them, need to share out 22.5 hours worth of work. So what we're going to do here is 22.5 divided by 3, which will tell us how much work they're to do each. 7.5 hours each will total up to 22.5 hours of one person's work needed to be done. So, like I've said, 22.5 hours of work shared between 3 cleaners is 7.5 hours of work per cleaner. Like so. Next, though, for the next bit of information we're given, is each cleaner is paid £8.20 for each hour or part of an hour they work. So because they've worked part of an 8th hour, they get paid essentially for 8 hours each. So each one's paid for 8 hours. Finally, it says how much will each cleaner be paid today. So each cleaner will be paid for 8 hours worth, 8 hours of work, so they'll get 8 hours multiplied by the hourly rate. So 8 times £8.20 will tell us how much we get paid each for today. So 8 multiplied by £8.20 is 65.6, which is £65.60. It's not £65.06. So that's how much we all each get. Question 10. We've got a part of a distance time graph for a car's journey. First, it says between which 2 times does the car travel at its greatest speed? It's travelling at its greatest speed when the gradient is the steepest, that when the distance is increasing faster. So between which 2 times? It's between these 2 points here. So it's between 0 seconds and 20 seconds. So between 0 seconds and 20 seconds. And the reason, because the gradient is the steepest. Well, gradient here is greatest. Not it greatest. Can't spell today. Gradient here is at its greatest. So, work out this greatest speed. Well, if we were to work out the gradient, it'd be a change in distance divided by change in time. But that's how we define speed. Speed is distance over time. So the speed is going to equal the gradient, essentially. So between these 2 points, between 0 and 20 seconds, we need to work out the change in distance and the change in time. So at this point here, the change in distance has gone from 0 up to this point here. Now each little square is worth 20 meters, I mean to say. So that's 300, that's 320, 340, 360, that point is. So the change in the y-axis is 360, it's gone from 0 up to 360. And the change in the x direction, it's gone from 0 seconds to 20 seconds. So that's just simply 360 divided by 20, and that will give you 18. So the speed, at its greatest speed, is 18 meters per second. Question 11 is about these pie charts. So we've got two different pie charts here, giving information about the ages in years of people living in two towns, Adley and Bridford. And your exam paper does say the diagrams are accurately drawn on. So these diagrams are drawn to scale. The ratio of number of people living in Adley to the number of people living in Bridford is given by the ratio of the areas of these pie charts. Now these diagrams are drawn accurately, so what we can do is actually measure these pie charts. So what we need here is a ruler. So if we just take this one and measure either the radius or the diameter for Adley, like so, we should see that that's 5 centimeters. So for Adley, the radius is 5. Whereas if we try for Bridford now and work out this radius, you can see the radius is 4 centimeters. So the area for the Adley circle, so area is pi r squared, so pi times 5 squared, your calculator will tell you 25 pi. Whereas for the Bridford pie chart, again area is pi r squared, but this time the radius is 4, so pi times 4 squared is 16 pi. So, like it says here, the number of people living in these places is proportional to the areas of these pie charts. It says, what proportion next of the total number of people living in these two towns live in Adley and are aged 0 to 19? So it does say total number, so that's going to be proportional to the total area. So for this one and this one, the total area of these two pie charts is 25 pi plus 16 pi. If you don't trust yourself to do it because it's got pi's involved like algebra, just try it with a calculator. 25 pi plus 16 pi, total area is 41 pi. And that's going to be proportional to the total number of people. So what we're asked here is the proportion of people living in these two towns that live in Adley and are aged 0 to 19. So we're looking at this sector here, living in Adley and between 0 and 19. I hope to your exam you brought your protractor, because that's what we're needing here. So we get the protractor out, like so, and we put the middle of the protractor, the crosshairs, I think of it as, over the exact middle of the pie chart. Next, what we do is we get this line here, starting at 0, and we put it on top of where the sector begins. So if I put that 0 line on top of there, like so, now I'm wanting to stop measuring when I get to this line here. So the sector begins there for 0 to 19 and ends at that point. So always count up from 0. So 0, 10, 20, 30, 40, 50, 60, 70. So the size of that sector in terms of degrees is 70 degrees. So because area is proportional now to the number of people, we can say that the proportion of people that live in Adley and are aged 0 to 19, well, this proportion is going to be that fraction of a full pie chart. So it's 70 degrees out of a full 360. So that's a fraction of a pie chart multiplied by the total area of that pie chart, which is 25 pi. So that, as a proportion of the total number of people, the total number of people will relate to the total area of these pie charts, because it says here the number of people is proportional to the areas. So total number of people will relate to this total area, which is 41 pi. So as a proportion, this proportion here, which are in Adley and between 0 to 19, divided by the 41 pi in total, will give us our solution. So what we've got here is on top 70 over 360 multiplied by 25 pi, all of which divided by 41 shift pi, gives us this awkward looking number, but it says give the answer to 3 significant figures. That means it either wants the proportion expressed as a decimal or as a percentage. I'm going to give mine as a percentage. To go from a fraction to a percentage, we just simply multiply by 100. And if we do that and press SROD, we get here 11.8 with a 5 next to it. So to 3 significant figures, it's either going to be 118 or 119. Well, because next to the 8 is a 5, that forces this 8 to round up to a 9, so we've got 11.9%. And that's the proportion living in Adley between 0 and 19. That's a proportion of all the people living in Adley and Bradford. Question 12, we have a portion of a regular polygon, a regular 12-sided polygon in fact. So we're told RT is a diagonal of a polygon. Don't worry about the word diagonal. All it means is it's a line that joins 2 points together, where the 2 points on the edge of the polygon aren't right next to each other. We need to find the size of angle STR and show every bit of our working if we can. So let's just dissect the question carefully. So first of all, we're told it's a 12-sided polygon and also that it's regular. If a polygon's regular, what this means is the sides are all the same size. So RS and ST will be equal length. These dashes just mean equal length, so we can add this to our working in a moment. Essentially, this is a triangle with 2 sides the same length, so therefore triangle RST must be isosceles, because RS equals ST. We next need to find angle STR, which is this one in the corner. Remember, always the middle angle, the middle letter rule, so we want to find the angle at T, which is this one over here. Okay, now as well as that, because we know this is now isosceles, we should be able to deduce that this angle here will also be the same. Isosceles triangles, remember, have 2 angles which are the same, as well as 2 sides which are the same. So this angle R will be the same as the angle at T. So what I'm going to suggest we do is we give these angles both a name, because they're both the same, give them both the same name, and just call them maybe X or Z or whatever you'd like. I'm going to call these both X, like so. Now we need to remember how to work out the exterior angle of a regular polygon. Sometimes we're asked to find the interior angle, but more times than not, finding the exterior angle is the way in to cracking the problem. So the exterior angle is this one I've just labelled on the outside. I've called it E for exterior. So to calculate the exterior angle for any regular polygon, what we need to do is take 360 and divide 360 by the number of sides of that particular polygon. That tells us what the exterior angle is. So here we're told what the number of sides is. It's a regular 12-sided polygon. So we can take this formula here and just substitute in the number of sides as 12. So if we do this now and use a calculator if need be, in fact I'd always recommend using a calculator if it's a calculator paper, we just need to do 360 divided by 12. because 12 is the number of sides. If you try that on your calculator, 360 divided by 12, that's going to give you 30 degrees. So the exterior angle is 30 degrees. Next, we're more interested in the angle on the inside, which is called the interior angle. So we need to work out this one now. So I'm going to call that I, just for interior. So you should notice, and ideally with enough revision, I know there's an awful lot to revise, so I'm not trying to lecture you or tell you off, but hopefully remember that the interior and the exterior, because they always lie on the same straight line, they need to add up to 180 degrees. So therefore, we can say the interior angle must be 180 minus 30, which is 150 degrees. So the justification is sort of embedded in the working here. We sort of know that the examiner can know that you know that the exterior plus interior add up to 180 by showing this clearly in your working. You use the number 180, then subtract the 30. So now we can say that 150 degrees plus 2 of these x's must add up to 180 degrees. Now, as obvious as this sounds, it's worth saying, because it's showing all your working, that angles in a triangle add up to 180 degrees. So you can explain that option if you want to, or just show your working clearly. So 150 comes from this interior angle. X, because we know this one and that one are the same, add up to 180. If we now subtract 150 from both sides, we see that 2x must be 180 minus 150, which is 30 degrees. Finally, dividing by 2, x must be 30 divided by 2, which is 15 degrees. Question 13, we're looking at Mr. Veal, who bought a company. The value of the company was £50,000. Each year, the value of the company increased by 2%. We need, for part A, to calculate the value of the company at the beginning of 2017. Give the answer correct to the nearest £100. So, what it says here is that the value of the company increased by 2% each year. Now, what I try and tell my students is that you always start off with 100% of an amount before anything happens to it. So here, we start off with 100% of its own value. If it increases by 2% each year, that means we need to add on 2% of its current self. So 100% plus 2% means at the end of each year, it's become 102% of what it used to be at the beginning of that year. Now, if you try on a calculator what 102% equals, 102 shift percent, press equals, you'll get 1.02. And that's called, by some people, including myself, that's the decimal multiplier. That's what we multiply the amount by for each and every time an increase occurs. Now, this increase is incurring every year, each year. So what happens here is the company starts off being £50,000. Then 1 year, it increases by 2%, so we multiply by 1.02. That's the same as saying we're working out 102% of what it used to be at the start. That'll tell us the increase for 1 year. We then need to multiply again to find the increase for the second year, multiply by 1.02 again for the third year, and so on, and so on, and so on. Now, we could simplify this by just multiplying 1.02 to the power of how many years we're talking. So here, we want to work out the value at the beginning of 2017. He bought this company at 2009. So how many years have passed in between these 2 years? Well, 2017 minus 2009, that equals 8 years. So it's increased by 2% 8 times. So we need to multiply by 1.02. We need to increase by 102% 8 times. So this is the formula for working out the final value at the end of these 8 years. So this is what we type into our calculation machine, often known as a calculator. So 50,000 times 1.02 to the power 8 gives us this fairly awful looking number. So let's just write it down, then we can talk about it in a moment. 58,582 and 0.96905. But look at the question, look at what it's asking us. We want the answer correct to the nearest £100. So just say this quietly in your head. Don't say it out loud in an exam, otherwise you get into trouble. 58,500, so this is the hundreds, £582. So we're interested in this bit of a number. This tells us the hundreds. We've got 58 grand, 582. So is 582, is that closer to £500 or closer to £600? Obviously it's close to £600, so we round that to 58,600. So the answer for that one, for part A, is 58,600. Next, part B could really throw you, but I'm going to try and explain it in a friendly way if I can. So at the beginning of 2009, the value of a different company was £250,000. In 6 years, the value of this company increased to £325,000. This is equivalent to an increase of X% each year. Find the value of X. Give your answer correct to 2 significant figures. What we can do, if we're being a bit clever, is we can adapt the idea from part A to help us in part B. So part A, what we did, is we took the starting value, 50,000, and multiplied it by this number here to the power of how many years it was being invested for, or how many years have passed, I should say. So this is the initial figure, so in our case it's £250,000 for part B. When we multiplied by this number here, now 1.02, 1 because 1 is 100%, 1 full unit is 100%, and 0.2 because 0.2 is the percentage increase. But here, we're not told what the percentage increase is. So I'm going to leave that as just a question mark, because I don't know what this X is. Got no idea. But looking at part A, whatever this value is, this decimal multiplier, which is this question mark for part B, I do know I need to multiply that by itself how many times the years have gone on for. So it's 6 years in this case. So if 6 years means I multiply that by the power 6, and that's going to equal, well, what it equaled here is the value after those how many years. So after 8 years, I've got the value here. So after 6 years, this will give me the value over here. Now we're told what the value is after these 6 years. It's £325,000. So £250,000 multiplied by something, multiplied by the same something, multiplied by the same something 6 times in a row gives us £325,000. We can then work out this by rearranging this equation. So if I divide both sides of this equation by 250,000, I can work out what this mystery value to the power 6 actually is. So 325,000 divided by 250,000. One too many zeros, sorry. Gives me 1.3. So I need to work out what this value is on its own. If this was something squared, I'd do the squared root. If it was this question mark cubed, I'd do the cube root. Whatever this number is here, I do that numbered root. So I need to do the 6th root of 1.3. So how do I do that on a calculator? So I press Shift, then the root button. No, I don't, I'm talking absolute rubbish. Sorry. Shift, then the power button, rather. It's different on different calculators. For this class whiz, it's Shift and the power button. So type in here 6 to find the sixth root, and then 1.3. Press equals. I get 1.044697, and so on. 1.044697, and so on and so on. Now I need to find the value of x, where x is the percentage increase each year. So if we compare this to what I had before, when the increase was 2%, the number, how it relates to this question mark here, was the second decimal place and everything after it. So the second decimal place and anything after is the percentage increase. So 1.0 is just for 100%. This here is the extra increase. So therefore, we can say that the percent increase, x, in other words, is going to be this number here with the decimal there. So here 1.02, that was 2%. 1.04 is going to be roughly 4%. So we put the decimal in after the 4, so it's 4.4 roughly. But look at this 4 here. That second 4 is before a 6. So that 6 will force this 4 to round up. So it's roughly 1.045, which means that the percentage increase to two significant figures would be 4.5%. So x equals 4.5. So x% means 4.5%. Question 14, we need to do some inequalities on a grid. So it says on the grid, shade the region which satisfies all of these inequalities. So the first one we need to do is y being greater than 1. What we should do first of all is just consider what y equals 1 would look like. So y equals 1 would be a straight line, horizontal, through cutting the y-axis at y equals 1. We now return to think about this inequality. It's strictly greater than. If I add a greater than or equals symbol underneath, then we'd fill the line in full. But because it's strictly greater than, we need to do this as a dotted line. So the line needs to look like this. Next, we need to think about what side of the line we want y to be on. Well, we want y to be greater than 1, which in terms of this diagram means y higher than 1, because y obviously goes up and down. So we want y to be on the big side here, so we want y to be up at this end, not down here. So anything down here I'm just going to cross off as a reminder to myself, this is the region I don't want to shade in. Nothing down here, because I want y to be greater than 1. I want y to be up here. Next, we've got x plus y needs to be less than 5. Let's rearrange this into the form y equals mx plus c. Always have it y equals if possible. So think of it as y equals, subtract x from both sides, we get y equals minus x plus 5. So this would be a straight line graph. The gradient would be minus 1, because we're talking minus 1x. And the y-axis intercept would be at positive 5. So it'd cut here. And then, because it's got a gradient of minus 1, it means every time x goes along 1, we go down 1 unit for y. And so this line here, y equals minus an x plus 5, would look like this. Goes down, 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 like so, for gradient of minus 1. And just to extend it backwards as well, it looks like this. However, like the first line, this is a strictly less than or greater than, so this line as well needs to be a dotted line, like so. Next we need to think about what side of the line we want y to be on. It wasn't really an equal sign, as you know, it was actually this symbol here, so thinking of it as it actually should be with this symbol means I want y to be less than, smaller than this thing here. If I want y to be small, I want y to be low, down on this side. So I want y to be below the line, not above, so I cross off anything above the line as a reminder to myself. I don't want anything up here. The last one, y greater than 2x, again, we think of it as y equals 2x first. What would the line y equals 2x look like? Well, it'd have a gradient of 2, and it would go through the origin because there's no plus c item here. There's no y-axis intercept listed, so it's got to have a y-intercept of 0. In other words, like I've said, it goes through the origin. So a gradient of 2 going through the origin would look like this. 1 along, 2 up, 1 along, 2 up, 1 along, 2 up, like so, and carry on going downwards as well. But of course, because it's still strictly greater than, I need this line to be dotted too, like so. Finally, I want y to be greater than minus 2x. I want y to be on the high side, not the low side, so I cross off anything on the low side. So I don't want anything down here. So now what's left? The region that's left that satisfies all these is the bit of a graph which doesn't have any of these crossed off bits on it. The only thing not crossed off is this region here. And so what I'm going to shade in is this region like so. And that's what you need to shade in as well on your exam paper. So it's everything here like so. You don't need to colour it in with a felt tip or anything like I'm doing, but clearly needs to be shaded in some colour, or if you're using a pen, make it clear which bit region you're shading in. So that's what we're after here, that bit of the graph. Question 15. Tracy is going to choose a main course and a dessert in a cafe. She could choose from 8 main courses and 7 desserts. Now she reckons that the number of ways of choosing a main and a dessert together is if you just add 8 plus 7. So she's thinking there's only 15 choices. Is she correct? Give a reason. Well, she's not correct. There's more ways of doing it. So no, she's incorrect. What she needs to do is multiply 8 by 7. So here's Mr. Bailey's made up menu to make it clear to you. So imagine the mains. We've got 8 choices: fish and chips, bangers and mash, veg lasagna, chili con carne, and so on. 8 choices. And then desserts, 7 choices down here. It's actually 8 times 7. If I put a tick here saying I want to have fish and chips and ice cream, I'd put a tick there. But because I've got 8 columns and 7 rows, I've got 8 times 7 possible boxes to tick. That's trying to make it clear to you. I'm not saying do your own menu in the exam, of course. This is just to illustrate why she's wrong and why it is 8 times 7. It's 8 columns times 7 rows, if you actually imagined it as a tick box exercise. Part B, 12 teams play in a competition. Each team plays its other team exactly once. Work out the total number of games played. So what I'm going to do here, I'm going to explain why the answer is what it is. If I just told you what the rule is, it might not help your understanding. So I'm going to first of all just put on this screen 12 possible teams, just called A, B, C, D, and so on. So here are the teams, let's imagine them. So 12 teams, 12 boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's start with box A, then go along accordingly and see if we can spot a pattern. So if each team plays each other once, Team A would have to play Team B, C, D, E, and so on, which can be imagined like this. So that Team A, which is one team, needs to play all of the 11 others. So if you start with Team A would play 11 games against all the 11 other teams. So we've done Team A. They can now sit out, if you like. Now imagine Team B. Well, Team B's already played Team A, so Team B would have to play C, D, E, F, G, H, I, J, K, and L. So Team B would have 10 games to play because they've already played Team A when Team A went first. So then Team B would play 10 games. So 11, then 10. Now imagine Team C. So Team C has already played B and A, so Team C needs to play D, E, F, and so on. So how many games, assuming A went first then B, now A and B have sat out, C will be playing 9 games. 11, 10, 9. Hoping you can see the pattern now. Just do one more for you. Team D, if they went next, A, B, and C have already played each other, and everyone else. So D just needs to play E, F, G, H, I, J, K, and L. So D would play these. D would therefore play 8 games in addition to what's been played before. So this pattern would go on and on and on until there's only just one more game left to play for the whole competition. So 11, 10, 9, 8. So it's going to be 11 plus 10 plus 9 plus 8 all the way down to 1. So luckily it is a calculator paper, so this isn't as painful as it could have been normally. So let's just work this out carefully. So 11 games just hidden by the calculator is the first one. Then 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 gives us a total of 66 games in this competition. Question 16. Solve x minus 2 equals 3. Give your solutions correct to 3 significant figures. So we start with this. What I'd suggest we do to get rid of this square symbol is just square root both sides. We then get x minus 2 equals the square root of 3, but be very careful here. For example, the equation x squared equals 36, I could say x equals 6, but also minus 6 times minus 6 would work, so we always need to remember plus or minus. So importantly, we do plus or minus the square root of 3. Finally, just add 2 to both sides, we get x on its own. So therefore, x will be positive 2, either plus or minus the square root of 3. So therefore, x equals, well, it could be where it's 2 minus the square root of 3. So we try that one first. 2 minus the square root of 3 gives us this. Press S arrow D to get it into the correct form. Now we want our answers to correct to 3 significant figures. So we'd have 0. First, second, third significant figure. So 0.267 maybe, but next to that 7 is a 9, so we round the 7 up to an 8. So first solution is 0.268. Or it could be where x is 2 plus the square root of 3. So if I just toggle back now, change a minus to a plus, press S arrow D to 3 significant figures, we'd have 3.73. That 3 doesn't round up to a 4 because 3 is next to a 2, which is less than 5. So those are the 2 possible solutions for what x could be. Question 17, we have a histogram to draw. So first of all, we've got a table that gives information about the heights of 150 different students. On the grid, we need to draw a histogram for this information. Well, histogram relates frequency, class width, and something called frequency density. So we need to remember this formula for histograms, which is as follows. FD, frequency density, which goes up on the y-axis, is the frequency for each interval divided by the class width of that particular interval. So we've got for frequency We can work out the class widths from here, no problem, but we need to include an extra column here for frequency density. So what I'd suggest we do is add one on like this. So as well as that, we also need to work out the class width, so maybe add in a column for class width like so. And all class width means is just the distance in between one interval end point to the other interval end point, the difference between the upper and lower bounds of the interval. So for this first one, from 140 to 150, that's a width of 10, because 150 minus 140 is 10. So we add this in like so. For the next one, from 150 to 155, that's a width of 5. From 155 to 160, again is a width of 5. Same here. And finally, for 165 to 180, that's a gap of 15. Now we can work out the frequency densities by taking each frequency and dividing by the class width. So for this first one, 15 divided by 10 gives 1.5. The next one, 30 divided by 5 is 6. 51 divided by 5 gives you 10.2. 36 divided by 5 is 7.2. And finally, 18 divided by 15 gives 1.2. So we can now work out the scale needed on this axis. So the frequency density needs to go up to at least 10, 10.2, so maybe 12. So let's think, what could we go up in? 1, 2, 3, 4, 5, 6. If we went up in 1s, it wouldn't fit on. Let's try going up in 2s. 2, 4, 6, 8, 10, 12. Going up in 2s would be a sensible scale for the frequency density, so let's do that. So we can label on the frequency density 2, 4, 6, 8, 10, 12, and so on, like this. That's fine. Now this scale here is for the heights. We don't need to start from 0. In fact, it'd be silly to start from 0. Start from 140. So 140, 50, 60, 70, 80. I'd suggest each big square, it goes up in 10 centimetre blocks. So the scale I'd suggest for the bottom is as follows for the heights in centimetres, stopping at 180. Now we're just adding carefully the actual blocks, and they must touch in a histogram. So the first one, it's 10 wide, so it goes from 140 to 150, and 1.5 high, so it goes up to 2.5 squares above where it would be a frequency density of 1. So the first box would look like this. The next one's going to be 5 wide, from 150 to 155, and going up to 6. The next one, again 5 wide, and goes up to 10.2, which is at this point here. Then 5 wide goes up to 7.2, that's 7, so an extra square up on 7 is there. So from 160 to 165 is going to fill in here. And the final one is the shortest, 1.2 is a height here, goes from 165 to 180, like so. So that's the completed histogram. Next, for part B, we have to work out an estimate for the fraction of students who have a height between 150 and 170 centimetres. So I want to include only students between 150 and 170, like this. So what we do here is think about what bars are included. Well, from 150 to 155, it's all of this bar here. So from 150 to 155, that's 30 students. So we've got 30 students there to include. From 155 to 160, it's all of that bar, which is 51 students. From 160 to 165, it's all of that, it's all of those 36 students. Then here, you should notice it's a third of this final bar from 165 to 180. So I've split this into thirds. I'm just wanting that piece out of 3. So here, it's going to be 1/3 of the total students represented by all of that bar. So it's 1/3 of 18, which is 6. So the fraction of students who have a height between 150 and 170 is 30 plus 51 plus 36 plus 6 all over the total number of students, which we're told is 150. So if we work this out on the calculator, so we've got 30 plus 51 plus 36 plus 6 all over 150, press equals, we get 41 over 50. And that's our estimate of all those students. A fraction of the students have a height between 150 and 170. Question 18 now. At time t equals 0 hours, a tank is full of water, but it's leaking. At the end of every hour, there's 2% less water in the tank than at the start of the hour. The volume of water in litres in the tank at time t hours is Vt. Given that we start off at 2000, then Vt plus 1 equals K times Vt. Write down the value of K. Now this is a bit of a nasty question. It's actually really simple, but it's worded in the most terribly difficult way that it makes it seem much harder than it actually is. Look how many marks are available. There's a little trick. There's 1 mark for this question, so it's not going to be as hard as what it seems. It's leaking, okay? So 2% less water each time. What this means, Vt plus 1 equals the volume of water this hour. That's 1 hour ahead of Vt. So Vt means volume the hour before. So how do we go to work out the current volume based on the volume it was an hour before? Well, it's losing 2% of water each hour. So remember, you always start with 100% of a volume, 100% of an amount, sorry. If it's increasing, we add on a percentage. If we decrease, we subtract a percent. So because we're losing water, each hour is going to be 2% less. So 100% minus 2%, because it's 2% less water, that gives 98%. And let's work out what this is on a calculator. What is 98% in particular as a decimal? That's 0.98. So all this means is, to work out, by the way, this is called a decimal multiplier, which I mentioned earlier in the paper, we multiply the previous hour by 0.98. So to work out the volume now, it's going to be 98% of the volume it used to be. In other words, it's 0.98 multiplied by the previous volume. So that is essentially the answer for what K needs to be. K is simply 0.98, because that's a decimal multiplier that works out 2% less than the previous amount. Question 19 is about coordinate geometry, and we have an awful lot of information to digest. So we're told we have a triangle with vertices, which just means corners, P, Q and R. The coordinates of P are -3, -6, coordinates of Q are 1, 4, coordinates of R are 5 and -2. We're also told M is a midpoint of PQ and that N is a midpoint of QR. Prove that MN is parallel to PR, you must show each stage of your working. Because there's so much information here going off, and when we're talking about coordinates, it's often quite visual, I would recommend strongly doing a sketch of everything that's happening so you can visualize and see much better what needs to be done. So taking this step by step and putting it into some sort of sketched diagram, let's have a look. So the first thing is, let's get a coordinate grid up, so X and Y. The first thing we're told is coordinates of P are -3, -6, so P is somewhere down here, so let's sketch in P. Next we're told about Q. We're told Q is 1, 4, so Q is 1 along, 4 up. Q somewhere here, let's add in Q. Then we're told about R. R is 5 along, 2 down, so R is going to be somewhere down here. Sketch this in. So R needs to go there. And next we're told about M. It says M is a midpoint of PQ. So from P to Q, If you imagine a line drawn here, and M would be in the middle of that line. So the middle of the line is going to be somewhere here, perhaps. So M, like I said, midpoint of PQ. Let's add that on. And next is all about N, which is the midpoint of from Q to R. So if you imagine a line from Q to R, draw that on, and M would be the midpoint, N would be somewhere here. And I'm saying somewhere very loosely. We can calculate this in just a moment. So if we draw this in and label N, like so. Now what we're wanting to do here is prove that MN is parallel to PR. You must show each stage of your working. So the key point hinges on this. If two lines are parallel, you don't need to write this down for the examiner, I'm just showing this for you. If two lines are parallel, they have the same gradient, simple as that. So what we need to do here is see if we can work out the gradient of from M to N, and then the gradient from P to R. So first of all, let's think about M. So M is the midpoint of PQ. So to work out the coordinates of a midpoint, what we do is we think, what are the middle of the x-coordinates? So P is -3 for x, Q is 1. So we need to average out those points. So -3 plus 1 divided by 2. And then the midpoint for the y-coordinate is going to be the y-coordinates for P and Q averaged out. So we take the mean of -6 and 4. So -6 plus 4 divided by 2. Another way you can think of this, if you're fairly good with these, is just literally imagine what's halfway between these two values. What number would be halfway between -3 and 1? That'd be -1. Alternatively, -3 plus 1 is -2, and half that. You get -1 using this idea of using a formula for it. In the exact same way, -6 add 4 is -2, half of -2 is -1. And again, halfway between -6 and 4 would be the point -1. So that's M. M is at -1, -1. Do the same for N. So N is halfway in between Q and R. So the x-coordinate of Q is 1, and the x-coordinate of R is 5. Halfway between 1 and 5 would be 3. If you want to use the formula, you can. So you can do 1 plus 5, then half it, which you would see would be 3, because 1 plus 5 is 6, half of 6 is 3. Then the y-coordinate, what's halfway between 4 and -2? So 4 plus -2, 4 minus 2, if you like, divide by 2. 4 take 2 is 2, divided by 2 is 1. So again, you could have just thought, well, what number is halfway between -2 and 4 on a number line? It'd be the point 1. So now we know the coordinates of M and N. We can now think about the gradient of M and N. So therefore, what's the gradient of this line that goes between M and N? Well, the gradient is always the change in y divided by the change in x. So if I just do a little sketch in addition to this original sketch for M and N, I just put M and N here in this sketch, do a straight line through them. So M, we're told, well, we worked out that M is -1, 1, whereas N is 3, 1. So the change in y is just how far up we've gone to go from M up to N. So we've gone from a coordinate of -1, so that should be a -1, up to 1. Just change this to a minus. So to go from -1 up to 1, that's an increase of 2. And for change in x, if we've gone from -1 up to 3, That's a change of 4. So it must have gone 4 along. You don't need to do the sketch, it's optional if it helps you to understand it better. So 2 divided by 4 for a gradient of mn is a half. Next we think about the gradient of from P to R. So what's the gradient of the line that goes through P and R? Well, again, gradient is always change in y divided by change in x between the 2 points we're considering. So the y coordinate at R is -2, and the y coordinate of P is -6. So we've gone from -6 up to -2. So again, we can consider this in much the same way as what we did before. So think of it like this. From -6 up to -2 is an increase of 4. And the change in x, well, P was -3, which then gone up to 5. So -3 plus 3 gets you to the origin, plus another 5 gets you to 5. So it must have gone along by 8. So the gradient's 4 over 8, which simplifies down to a half. So therefore we've proven that the gradients of mn are the same as the gradient of PR, they're both equal to a half. So then we can finally say, therefore, mn is parallel to PR because both have gradient a half. And that's question 19 done. Quite tricky, but a diagram I think massively helps you. Question 20. Again, these questions do get quite a bit harder towards the end, but it's a case of picking up what marks you can, and all marks help. So OAC is a sector of a circle, centre 0, radius 10 metres. Just a bit of trivia, if you were to work out the area of this sector, you've got a mark. Even if you don't answer the question fully, if you spot it's an area-based question, work out the area of a sector, you've got a mark. So always bear in mind, you can always attempt something. Anyway, talking through this question, BA is a tangent to the circle at point A. So this line BA is a tangent, BC is also a tangent to the circle at point C. That line there is a tangent too. The angle at the centre, angle AOC, is 120. Calculate the area of the shaded region. Give your answer correct to 3 significant figures. Well, let's put on a bit more information about what we know. What we need to remember from circle theorems is tangents meet the circumference at a 90-degree angle. So this angle here at A and this angle here at C will both be 90-degree angles. Both right angles, like so. Another thing about tangents that meet the circumference is that if tangents meet the same circle from the same point, those tangents are equal in length. So this tangent BA and the tangent BC are going to be equal lengths. As well as that, because O is the centre of a circle and A and C are points of a circumference, AO is a radius and OC is a radius. So these two lines, AO and OC, are the same as well. So I'll just annotate this on my diagram. This one from O to C is 10 metres. I'll label that in a moment. Next, this line here from A to C is common to this top triangle and the bottom triangle. So to work out the total area of this shape, which might be a good idea, I could consider this shape, which is actually a kite, the whole thing, in terms of two triangles, a bottom triangle and a top triangle. So, next, because this side's equal to that side, triangle AOC is going to be isosceles. It's got two sides the same, therefore for two base angles, these ones in yellow must be the same as well. Angles in a triangle add up to 180 degrees. If this one's 120, that leaves 60 to go, shared equally between these two. 60 divided by 2 means that therefore each of these have to be 30 degrees. But remember from before, this whole angle at A the whole angle at C was a right angle. So all of this was 90. All of this needs to be 90 as well. So if this is 30, what must this be so that 30 plus this adds up to 90, and the same at this end as well? Well, 30 plus 60 gives us 90. So these two angles here at A and C must be 60 degrees each. So actually, this top one, if those two are 60, 60 plus 60 is 120. That has to be 60 as well. So ABC, this top one, is actually an equilateral triangle. Finally, like I said, I'm just going to label on this side from from O to C as 10. So I'll just put this up there, like so. So what I could really do with doing is working out the length of A to C. Now what we need to remember here is the cosine rule. So A squared equals B squared plus C squared minus 2BC cos A. So A is the side we want to find. I'm going to label A to C side A. The angle opposite to A is angle A, so I'm going to call this my angle A. And in any order, B and C are the other two sides we know. So I'm going to call this one B, that one C. It wouldn't matter if I called that one C and B. All that matters are B and C are the other two sides which you do know. So if I substitute this in now, I can solve for what side A is. This formula can be used to work out what A is. I don't want A squared, I want what A is. So I could square root both sides. So using this formula, if I square root both sides, like so, and obviously the square root of A squared just becomes A. So A equals the square root of B squared plus C squared minus 2BC cos A. So using this, I can say that this side AC, which I've labelled A, so big square root, so I'm going to give myself lots of space. B squared is 10 squared, plus C squared, that's going to be 10 squared as well, minus 2 times 10 times 10, times cos big A, which is 120. So let's work this one out. So, got the square root of 10 squared plus 10 squared minus 2 times 10 times 10 times the cosine of 120. Close brackets. We get 10 root 3. Let's leave it in exact form so we don't need to incur any rounding error. So because I've got that's 10 root 3, I'm just going to label on that it is 10 root 3. So the bottom side of this top triangle is also 10 root 3, and because we've established it's an equilateral triangle, we now know that this side is going to be 10 root 3, and this side here is also going to be 10 root 3. So in terms of working out the areas, another formula we can use for the area of a triangle is a half AB sine C. So essentially we need to know two sides in between an angle we do know to work out the area of each triangle. So we've actually got this for both the top and bottom triangles. So here I'll just take this away and think about how I can work out the area of this bottom triangle. So area of this one. Well, I know two sides, either side of an angle we do know. That's how you work it out. So it's going to be half times 10 times 10 times sine of the angle in between. So that's little a, that's little b, that's big C in terms of this formula. So the area of this bottom one is going to be half times 10 times 10. Why did I put 0? That's very bizarre. Sorry, half times 10 times 10 times sine 120. So let's just see what that gives us. So a half times 10 times 10 times sine 120. That gives us 25 root 3. I can then do the same for this top triangle. Now I'm pointing not to the shaded area, I mean the whole triangle. So the area of this top triangle would be half. Well, I know this side's 60, so I know this angle's 60. I know all sides are 10 root 3, so it's going to be half times 10 root 3 times 10 root 3 times sine of 60 degrees. So same formula, just different numbers. So 1/2 multiplied by 10 root 3 multiplied by another 10 root 3 multiplied by sine of 60, close brackets. That gives us 75 root 3. So therefore, I can work out the total area of this shape OABC, or just total area of the whole shape. So the total area of entire shape is going to be 75 root 3 plus 25 root 3, which is 100 root 3. Next, I can work out the area of this sector here. So the area of a sector, we need to consider a sector as just a fraction of a full circle. So the area of a sector, it's not a full 360 degrees, it's not the full circle, it's just 120 degrees out of a full 360. So essentially this is 1/3 of a full circle. If you're not sure if it's 1/3, just think of it as 120 degrees out of a full 360. It's that fraction of the full area of the circle, which is pi r squared. Remember, area is pi r squared. So it's that fraction multiplied by pi times r squared. R is 10, so it's that times 10 squared. And let's see what we get there. So it was 120 over 360 multiplied by pi multiplied by 10 squared. So if you want to, you can leave it like that. We can always put it to 3 sig figs after, so it's 100 over 3 pi. Now the key thing to spot is this shaded area we can think of as being the whole of the shape. Take away the white bit here, which is the area of the sector. So the shaded area is going to be the whole thing, which is 100 root 3. Subtract the area of the sector, which is 100 over 3 pi. So 100 root 3 minus the answer I've just got gives me this. Now read the question carefully. I need to give this to 3 significant figures. So to 3 significant figures, 6, 8, 4. Does that 4 round up though? Well, that 4 is next to the 8, so yes it does. That 8 is 5 or higher, so that 4 has to become a 5. So we've got 68.5. And of course the units are meters, so the area is going to be meters squared. So that's question 20 for you. Number 21 is about counters in a bag. So it's going to be probability. So there's 12 counters in a bag. There's an equal number of red, blue, and yellow. So that's the first thing to mention. An equal number of red, of blue, and yellow. There's no other counters in the bag. 3 are taken at random. Work out the probability of taking 3 red counters. Well, if there's 12 counters in total and an equal number of red, blue and yellow, that must mean the number of red must be 12 divided by 3. In other words, there must be 4 counters of each colour. There must be 4 red, 4 blue, 4 yellow. So probability taking 3 is a probability the first is red, and then the probability that the second is red, and then, if you wonder why I'm saying "and" so strangely, just bear with me, I will explain. With probability, if you can think of it in terms of one thing happening and then the other, it's essentially a multiplication. If the probability that the first is red and then the other's red, means this one multiplied by the other probability. And then if the third one's red as well, we're multiplying 3 separate probabilities together. So, to begin with, if you take 1 red, there's 4 reds to pick from out of a total of 12, so that's going to be 4 out of 12. Next, if you dive your hand into the bag again, now there's only going to be 11 counters left to pick from, because you already picked 1 red out. So because 1 red's already been picked, there's only 3 reds left out of a total of 11 now. Then when you go for your third and final time, if you pick your third red, you've already picked 2 reds from before. There used to be 4 reds, but you've picked 2 out. That means there's only 2 left to pick from, now out of a total of only 10 counters. So this is how we're going to calculate the probability. It's 4 twelfths times 3 elevenths times 2 tenths. So what we're going to have here is our final answer is 4 twelfths times 3 elevenths times 2 tenths. So if we do this, we get 1 out of 55. So very unlikely that we'd pick all 3 of them being red. So 1/55. The next part of this question, all these counters are put back into the bag. Now some more counters are put into the bag, but there's still an equal number of red, blue and yellow. There's no more counters of any colour. 3 more counters are taken at random from the bag. Is it now less likely, or equally likely, or more likely that the 3 counters will be red? You must show how you get your answer. What makes this one confusing is, it says that some more counters are put into the bag, but it doesn't say how many. So what I'm going to suggest we do here is make up a number. Just make up a number and see what happens. Importantly, we're still told there's the same number of red, blue and yellow. So I don't know, let's go for maybe, could it be 20 each? Could it be 60 counters in total? So it's up to you what you pick, as long as it's bigger than 12. So let's try, and also it needs to be divisible by 3, because there's an even number of each. So let's go for, eeny, meeny, miny, mo, let's try 50 count, no, not 50, let's go for 60 counters. 60 total counters. Can't divide 50 by 3, that's a silly suggestion. So, in other words, 20 that are red, 20 that are blue, 20 that are yellow. So, if we had 20 of each, for probability of 3 reds, we just adapt what we did for part A. So probability of the first one to be red would be 20 out of 60. Then if we pick another red, there'd only be 19 to pick from, this time out of a total of 59. Finally, picking a third and final red, there'd only be another 18 reds to pick from, out of a total of 58 counters. So if we calculate this now, so we've got 20 over 60. I know that's a third, but I'm going to leave it as the exact numbers. 20 over 60 times 19 over 59 times 18, oops, need a fraction, times 18 over 58. That gives me 57 over 1711. Now ultimately, the actual value of this doesn't matter so much. All that matters is it less or more than 1/55th? So if I go a sad button, I get 0.0333-ish. But 1 over 55 was only 0.01 something. So importantly, this probability here is a greater probability than 1 over 55. So therefore, it's now more likely that the three counters will be read. So as long as you've tested clearly a different number which is greater than 12 and shown that this probability of getting 3 reds is greater than the probability than before, that's sufficient work to say therefore it's now more likely. You didn't need to try 60 total counters. You could have tried 90, you could have tried 30, as long as it's a divisible number by 3 and it's greater than 12. Question 22. We've got some functions to consider. So we've got f of x and g of x, where a and b are constants. G of 3 is 20. F to the power minus 1 it looks like. This just is notation for the inverse function of f. So the inverse of 33 is the same as g of 1. Find the value of a and b. So I'm going to just focus on this inverse function idea and just explain how we calculate how to get the inverse function. I'm going to do this using a flow diagram. So if we think about what fx is, fx means when the input is x, f of x comes out to be 5x plus 3. So if our input is x, the first thing that happens to x is we multiply by 5. That gives us the 5x. Then we add on 3. That gives us 5x plus 3. And that is what f of x is. Now, this means the inverse function, which means reversing the whole thing to get back to what x was to begin with. So now, if we go the opposite way, starting with x, do the exact opposites will tell us what the inverse function is. So go the opposite way and do the opposite things each time. So going backwards, instead of adding 3, we'd subtract 3. So just make a note of what's going on down here. After subtracting 3, before we multiplied by 5, opposite of multiplying by 5 is dividing by 5. So x minus 3, then divide by 5. That's what f minus 1 of x is. So therefore, our inverse function is f minus 1 of x is x minus 3 over 5. We can now use this in this question. So let's do the easy bit first. So g of 3 is 20. So when the input into g is 3, we get 20. So let's do this bit first. G of 3 equals 20. What this means is a times 3, in other words, 3a plus b equals 20, just by inputting the 3 into the place of x. Now this f minus 1 of 33 equals g of 1. So f minus 1 of 33, what we can do now using this f minus 1 function we just worked out, we can input 33 into this expression. So f minus 1 of 33 will be 33 minus 3, divided by 5, which gives us 6. So f minus 1 of 33, that equals 6. So I can say that g of minus 1 equals 6. So if I input 1 into g, that gives me a times 1, which is just 1a plus b. So a plus b equals 6. These are now two simultaneous equations which we can solve. If we notice here, we've got the same number of b's in each. Check the signs in front of the b's, because we've got one b in each. These signs are the same. We've got two simultaneous equations which are linear. If the signs are the things which have the same number in front, in this case a 1, and the signs are the same, we subtract. So we're going to do here the top equation, subtract the bottom. So 3a minus a would give me 2a, b take away b would cancel, 20 take away 6 is 14. So 2a equals 14, therefore a must equal 7. So that's the first solution to this problem. We've got what a is. We can now substitute a equals 7 back into one of these starting equations. So next I can sub a equals 7 into a plus b equals 6. So if a is 7, then 7 plus b equals 6, because a is 7. 7 plus b equals 6. Therefore, take 7 from both sides. B equals 6 minus 7. B has to equal minus 1. Question 23. S is a geometric sequence. So given that root x minus 1, 1, and root x plus 1 are the first three terms of x, find the value of x, show all working. Well, the most well-used sequences for GCSE are normally arithmetic, but geometric are a thing on the specification. With an arithmetic sequence, each term along you get from adding a certain number to the one previous. When it's a geometric sequence, we go from one term to the next by multiplying the previous term by a constant value. We can work out what this constant value is by considering the following. So because it's geometric, another way of thinking about this is the value of each term divided by the one directly before it is always the same, and that value is called the common ratio. So this is awkward. It's got algebra in it, but imagine this one here. Imagine, say, 2, 6, 18, 54. This is geometric. This is where each term is being multiplied by 3. 2 times 3 gives you 6. 6 times 3 is 18. And you can work out that we're multiplying by 3, because that's 6 divided by 2, which is 3. 18 divided by 6 is 3, and so on. So each term divided by the one before it will always be the same. And that's what we're going to use here. So if I just say goodbye to that. So the terms in a line, that'd be your first term, second, and third. So what I can say is that one divided by the one before it, so 1 divided by root x minus 1, must be the same as when I do root x plus 1 divided by 1. So now I've got one fraction equal to another. I can solve this by cross-multiplying fractions together. So that one times that one will equal this one times that one. So 1 times 1, really easy, I'll do that one after. This one here, root x minus 1 times by root x plus 1 equals 1 times 1, which is 1. If we look at this here, this is actually a difference of 2 squares. One thing minus one thing plus that same thing. What obviously is going to be, we're going to have root x times root x, which is just x, minus 1 times plus 1, that gives us minus 1, just equals 1. Therefore, if I add 1 to both sides, I'll get that x is equal to 2. I can only do this, and I can only know for definite there's no root x terms, because this is a difference of 2 squares. Don't go thinking that I can always just square the first thing, square the last thing, and that's it. I can only do that in this case because it's a difference of 2 squares. Next, show that the fifth term of s is 7 plus 5 root 2. So now I know that x is 2, I can fill in what the sequence is. So the sequence is root 2 minus 1, 1, root 2 plus 1. That's the fourth one. That's the fifth one. So I want the fifth term, I want to work out this one here. So what's the common ratio? Well, like I said before, the common ratio for a geometric sequence is what you multiply each term by to get to the next one. So to go from 1 to root 2 plus 1, I must have multiplied 1 by root 2 plus 1. 1 times root 2 plus 1 gives me root 2 plus 1. And so what must happen here is, to get to this next one, I'd need to multiply root 2 plus 1 by another root 2 plus 1. And to go to this one, I'd have to multiply by root 2 plus 1 again. So therefore, the fifth term, that's the first, second, third, fourth, fifth. The fifth term, I can start with the third term, which I know, which is root 2 plus 1. I'm going to multiply root 2 plus 1 by itself and itself again. So I'm going to multiply it by root 2 plus 1, then again. So I'm multiplying by root 2 plus 1 squared. So at this stage now I can use a calculator. This is proof that I know what I'm doing. So I'm showing what I'm doing. So that's fine. So the fifth term is going to be, in brackets, root 2 plus 1 times by root 2 plus 1 all squared, which gives me 7 plus 5 root 2, which is what I wanted to prove in the question. So we're done. We're done with question 23, because that's the last question, we've done the whole paper. Big sigh of relief. I do hope you found some of that useful. If you have, please do like the video and consider subscribing. I'd be really grateful. And best of luck in your mocks and your tests and generally in life. So take care of yourselves, and I'll hope to hear from you very soon. So goodbye from now. Have a lovely day.